Good afternoon, this is Schweitzer. I'm going to do what I have referred to as a roller coaster problem or pure energy problem number 1. So in this case, every problem of this type would be very similar. We essentially have something that is kind of going along up and down, and we want to know the speeds at certain points. Each of these points might have heights. So skiers on top of a hill, and it has a height of 100 meters. What's the skier's speed at the bottom of the hill, here at height equaling 0? And then what's the skier's speed at the top of the second hill? This second hill height equals 30. So this is a pure, didn't like that. Alright, so we'll down, up, and we'll like that. So at this point, this is a conservation of energy problem. Cannot use the kinematic expressions or equations for this. Simply being the kinetic energy plus the potential energy equals the kinetic energy plus potential energy, and the skier has all the energy that the skier is going to have will be there at the beginning based on its height, and it will stay consistent throughout. So in this case, this thing has 0 kinetic energy at the top plus mass times gravity times height, and then equals at point here. Now the skier gets to this point, okay, they're still moving, so they have some kinetic energy, 1/2 mass velocity squared, plus potential energy, because it is a certain height of the ground, mass times height times gravity. Mass being in every one of these can be excluded, so height times gravity equals 1/2 velocity squared plus height times gravity. This is at the top, and this is of hill number 1. This is at hill number 2. Okay, so let's plug our values in. Hill 1 is 100 times 9.8 equals 1/2. I'm looking for this value plus the height on top of hill 2 will be 30 times 9.8. Alright, so let's do the math. I want to solve for that guy. This is 980 equals 30 times 9.8 equals 294. Subtract that over equals 686 equals 1/2 v squared. Divide out by 0.5 and then square root this thing, and I get 37.0 meters per second. Okay. Now I just saw what I solved for. I solved for letter B there. It looks like unfortunately I had to B first. Okay. That would be this speed here would be at the very top would be 37 meters per second. Now in this case, let's do A. A just wants to know where am I going to be at the bottom. At this point, similar type problem. At the top we have kinetic energy plus potential energy equals kinetic energy plus potential energy. At the top I have 0 kinetic energy, at the bottom I have 0 potential energy. So this is mass times height times gravity equals 1/2 mass velocity squared. Mass cancels. Height of 100 times 9.8 equals 1/2 v squared. 980 equals 1/2 v squared divided by 0.5 equals square root this thing, and I get velocity equaling 44.2 meters per second. This is A and this is B. Pretty typical problem. You could have several hills in a way. in that sense. Other problems, they could assign a friction to this thing, and then at some point you could coast out and calculate your distance. But at this point, this type of problem, we'll just have this setup. Whether it's a roller coaster or some skiing, sliding, doesn't matter. That's it.